Hello viewers. Now we have another question on motion of projectile. We have a ski jumper takes off from the ramp traveling at an angle of 10 degrees below the horizontal with speed 72 kilometers per hour. Before landing, she travels a horizontal distance of 70 meters. Now, these are the questions. First, we are asked to find the time she's in the air, okay, and the vertical distance she falls. So to calculate the time she's in the air and the vertical distance she falls, okay, now we have a ski jumper takes off from the ramp traveling at an angle of 10 degrees below the horizontal with speed 72 kilometers per hour. Okay, so before landing, she travels a horizontal distance of 70 meters. So we're asked to find the time she's in the air and the vertical distance she falls. So which means, okay, the vertical distance she falls, according to the question, will be negative, okay, because the direction will be downward. This will be downward. Yes, the direction, the vertical distance will be downward. So if the vertical distance is downward, now the fact that we know that for acceleration due to gravity, okay, the value of g will be positive when the motion is vertically downward, but it will be negative when it is what? Vertically upward. Okay, so but in this case, so the first thing we need to do is to first, convert the speed, in kilometers per hour to what? Meters per second. Okay, let's have our solution. All right, so in this case, we have, okay, to be able to understand the question, let me draw the diagram, how I understand the question. Now we have, this is the ramp, this is the ramp. The angle of inclination is 10 degrees. Then the ski jumper, okay, we have the ski jumper. I say this is the ski jumper and this is the ramp. Okay, so at a speed of 72 kilometers per hour, so that means that, okay, so which means the initial speed, that's u, is 72 kilometers per hour. So then also we are giving angle of inclination. The angle of inclination, that's theta, that is given to be 10 degrees. Okay, then she travels horizontal distance of 70 meters. So that means for horizontal distance, that will be 70 meters. So we are giving x. Okay, this is the horizontal distance. So the first thing to do is for us to convert 72 kilometers per hour to meters per second. So that means we have our step one. Okay, convert the speed. Okay, convert the speed from kilometers per hour to meters per second. So that means the speed, which is 72 kilometers per hour, that will be 72. Okay, that will be 72 multiplied by 1000. Okay, divide by 3600. So this will be meters and this will be what? Seconds. Let's not forget that 1 kilo, okay, 1 kilometers equals to 1000 meters. Then 1 hour, okay, in 1 hour we have what? 3600 seconds. Yes, 3600 seconds. So that is the conversion we just did here. Okay, so we have, so dividing this by 100, this will be 10. Dividing this by 100, this will be 36. So what we have remaining is 720, okay, divided by 36. The unit now becomes meters per second. Okay, so, and then also we know that 72 divided by 36, that will be 2, but 720 divided by 36 will be 20. So the initial speed is 20 meters per second. 20 meters per second. So this is very important. This is the initial speed. Okay, so that's the initial speed. Before landing, she travels a horizontal distance of 70 meters. 70 meters. Okay, so that means the next thing we are going to do now, because here we want to calculate the time she's in the air, and to be able to calculate the time she's in the air, so that means we need to first find the horizontal component of velocity. Yes, because for horizontal distance, we're going to use the equation connecting horizontal distance and horizontal velocity. Yeah, so we need to find the horizontal component of velocity since the ski jumper covers this distance. Okay, so which means our step two, okay, is for us to resolve the velocity into horizontal and vertical components. Okay, so we know that for horizontal component is ux, and that'll be u cos theta. Okay, then for vertical components, we know that that'll be what? U sine theta. So this is horizontal component, or the horizontal velocity. Okay, why this would be vertical velocity? Okay, this is the vertical velocity. Okay, so now we know the formula for horizontal and vertical velocity. Why do we need these formulas, or why do we need the values for ux and uy? They are important because now we can see here that, okay, the way I understand the question is that for us to be able to calculate the time she's in the air, I mean the ski jumper, so it means we need to first calculate the horizontal distance, horizontal velocity. Okay, when we know the horizontal velocity, okay, that will help us, or lead us to how we'll be able to calculate or get the value for time t. Yes, this will be the velocity of projection. So we can now have ux equals to, so this velocity 20, then cos 10 degrees. Then also uy will be equals to 20, then sine 10 degrees. So let's get the values for each. Okay, so we have 20 cos 10 degrees. That'll be 19.7 meters per second. Then for 20 sine 10 degrees, okay, that will be 3.47 meters per second. So now we know that for horizontal component, that's the horizontal velocity, we have 19.7 meters per second. Okay, then for vertical component of velocity uy, that is 3.47 meters per second. Okay, now it's getting interesting. Okay, so step three will now be for us to calculate the time she's in the air. So it's now getting clearer. So we know that x, horizontal distance, so this is one of the equation of kinematics. Horizontal distance will be horizontal velocity multiplied by time. Okay, so we want to calculate the value of t, that's the time she's in the air. So where t represents time she is in the air, the time she is in the air. So we know that we can make t the subject of the formula from this. So we know that t will be equals to x over ux, so that t will be equals to horizontal distance. Remember, the value of x is what? 70 meters. So this will be 70 divided by the horizontal velocity, 19.7. So that will be divided by 19.7. So that means 70 divided by 19.7. Okay, that will be 3.55. So t equals to 3.55 seconds. 3.55 seconds. So which means the time she's in the air is what? 3.55 seconds. That's the time she's in the air. 3.55 seconds. Okay. Now step 4. Now step number 4. What are we looking at? Okay, now we want to find out the vertical distance she falls. Now, the vertical distance she falls, of course, because the motion is downward, it will be negative. But in this case, because the solution must be positive, so in this case, it will mean that, whatever value we have for the vertical distance she falls, okay, that means we have to take the absolute value of that value, okay. Now, that is when the value is negative, so we neglect the minus, okay. When we neglect the minus, then it means the positive of that value will become the vertical distance. So step 4, we want to calculate the vertical distance. So to calculate the vertical distance, we have what we call vertical initial velocity. Vertical initial velocity, okay. Then we know the time, okay. So we are going to use, we can make use of y equals to ut. So this time it will be what? Uy multiplied by t plus 1/2 of gt squared. Like I said, this will be negative. So that means this will be negative uy times t, then negative 1/2 gt squared, okay. Now in this case, for vertical distance she falls, I repeat again, because the direction is downward, then it will be negative. The value of g will be negative, okay, and u also will take negative value. So in this case, we're going to have y equals to uy, that is 3.47 multiplied by 3.47 multiplied by the time 3.55 minus 1/2 multiplied by 9.81 times 3.55 squared. Okay, so 3.55 multiplied by 3.47 multiplied by 3.47, that will be, so y will be equals to 12.33, okay, minus 12.33. So let's get the value for what is 9.81 divided by 2. That will be 4.905, then multiply by 3.55 squared. 3.55 squared, that's 12.60. Okay, 12.661. Okay, 3.55 squared. So we have 3.55 squared multiplied by 4.905. Okay, that'll be 61.82. So y will be equals to negative 12.33 minus 61.82. Okay, and y now becomes negative 74.15 meters. Okay, now neglecting the minus sign, y, which is the vertical distance she falls, will now be 74.15 meters. This is the vertical distance the ski jumper falls. Okay, that is, we have a ski jumper. A ski jumper takes off from the ramp, traveling at an angle of 10 degrees below the horizontal with speed, which is 72 kilometers per hour. So we convert the speed from kilometers per hour into what? Meters per second. So when we do that, then we can now resolve the velocity, which is the velocity we calculated here, which is 20 meters per second, into two components. Okay, so when we do that, we are doing that because we are asked to find the time she's in the air. And to calculate the time she's in the air, when she's in the air, she travels a horizontal distance of 70 meters, not when she lands. That's when she now travels horizontal distance of 70 meters. So that means the time she's in the air, okay, she travels distance of 70 meters. Okay, so then the value of ux, okay, we need to calculate the value of ux, which is what we have as 19.7 meters per second, and this is the time she's in the air. So for the vertical distance, like I said, the value of g will be negative, okay, not because the motion is downward, okay, because we know that when the motion is downward, when it is downward motion, the value of acceleration of free fall or acceleration due to gravity will be positive, but in this case it will be negative because she falls below the horizontal. So but even when we use, when we assign plus here, then it means this minus will not be there, okay, and at the end we're going to have the value of y to be what, to be positive. But for clear explanation, we need to understand that this will take negative, and this will also take what, negative. And when after we plug in the values and we're having a negative value for y, so we can just neglect the minus sign, or we could actually take the absolute value of minus 74.15 meters, so that the value of y can now be 74.15 meters. The noblest pleasure is the joy of understanding. Bye bye.